We have all been there. You are trying to watch a high-definition video on your phone, and instead of a movie, you are staring at a spinning circle, waiting for the screen to catch up. What you are waiting on is a hidden engineering process called video compression. To get large video files through the air and onto your screen, your phone has to do a massive amount of behind-the-scenes math to reconstruct the image. You can think of this process like solving a giant jigsaw puzzle on fast forward. To save time and data, your phone does not download every single pixel. Instead, it receives a fraction of the puzzle pieces and then mathematically guesses the shapes and colors of the pieces around them, filling in the missing blocks on the fly. Engineers have a specific system for this guessing game. It is a way for the computer to look at the puzzle pieces it already has to figure out the pieces it is missing. For your video to play smoothly, your phone has to solve these puzzles millions of times per second. If there is a single traffic jam in that process, your video stops and that spinning circle appears. For a long time, device software had a very rigid rule for how to guess those missing puzzle pieces, and that rule created a major traffic jam. Under the old rules, if the computer wanted to place a specific type of data, let's call it a red puzzle piece, it had to wait for the previous red piece to be completely finished and locked into place. This creates a waiting game. Because the calculation for the second red piece depends entirely on the first red piece, they are forced to stand in a single file line. If that first piece takes a fraction of a millisecond too long to process, the second piece has to wait, and the third piece has to wait for the second. The entire line stalls out, slowing down your device's processor. That single file line is what forces the computer to pause. When the computer waits, you wait. This is United States Patent number 10,419,763. It outlines a mathematical solution to completely eliminate that waiting game. The engineers who wrote this asked a simple question. Instead of waiting in line for the exact same kind of information to finish, what if the computer looked for clues in a totally different kind of information that was already sitting right there? Back to our puzzle. Under this new method, to figure out where a red piece goes, our first category of data, the computer stops waiting for the other red pieces. Instead, it looks closely at the blue pieces, a completely different category of data that are already sitting right next to it. By looking at an empty space and the completed pieces touching it, the computer creates a tiny, self-contained neighborhood. This little circle of neighbors gives it all the clues it needs instantly. You can see these neighborhood blueprints in this diagram from the patent. Look at the grid shapes labeled 610, 620, and 630. The dark shaded blocks show the empty spot, and the lighter blocks map out the surrounding neighbors. The math relies on those specific neighbors to fill in the missing clues. Because this neighboring data is locked in place, the computer already knows the answer. It doesn't wait in a single file line anymore. Dividing the work this way enables parallel processing. Instead of calculating one puzzle piece at a time, your phone can now look at hundreds of these little neighborhoods and calculate them all at once. By simply changing where the computer looks for its clues, a sluggish one-by-one process becomes a high-speed parallel grid. This concept is mapped out as official instructions. This flowchart shows how data is handled. Right here in box 720, it confirms the core rule. Guess the first piece of information by looking at a different category. That mathematical step breaks the traffic jam. When you translate that math off the page and put it into the microchips inside your TV and your phone, the data flows smoothly. Because the processor handles information in parallel, your device can play massive, data-heavy 4K and 8K videos without ever stuttering to catch up. Because the microchip works efficiently across the whole board, instead of straining against a single line, it uses significantly less power. Your battery lasts longer. By looking at the puzzle pieces sitting right next door, engineers cleared the path. That is why you can stream a high-definition movie flawlessly on a battery-powered piece of glass in the palm of your